Hi Sola, I got your email about asking for help with the optimization problems, and I'm happy to help you. I've got the first two assignment questions here on the screen, and I'm hoping that if I get you started on them, that it will help you to understand how to do the others and to apply what we're talking about to the other questions. So let's start with question one. With question one, we have two non-negative numbers, and their sum is 9, and so that's enough information for us to make our first equation. If we have the two numbers and we represent them as x and y for now, then x plus y equals 9. So from that, we could say that y is 9 minus x if we just solve that equation for y. So we could say that our two numbers are x and 9 minus x. So that's a really good start. Now when we read the second line of the question, it says that the product of one number and the square of the other number is a maximum. So the product, P for product, of the first number and the square of the other number, it needs to be a maximum. So in that case, we're multiplying the first number by the square of the other number, and so that's going to be x times 81 minus 18x plus x squared when we expand that binomial, which will leave us with 81x minus 18x squared plus x cubed. In order to find the maximum or the minimum, we always take the first derivative and we take that derivative and we set it equal to 0. Now, you're going to try to factor this result and find the value of x that gives you an answer of 0. What I'm doing here is common factoring for you. Your factors are going to be x minus 9, x minus 3. So the two values of x that satisfy this equation are x equals 3 and x equals 9. All right, so now what we have to do is think about the question, and the question said that the two numbers have to add up to 9. That means the sum is 9. If we choose this value for x, that would mean that the other value is equal to 0, the other number. And that's impossible because we're not going to get a maximum product if that's the case. We would have, up here, we would have for the product 9 minus 0 equals 0. If we choose this number for x, then the other number, y, would be 9 minus that number, or y would be 6. That's going to give us the maximum. If you try it back in the product formula, we'll end up with 3 times 6 squared, or 3 times 36, and that will give us our maximum product. The other way to test and see if that's a maximum when you're doing optimization is to find the double derivative and then test the value 3 and 9 in that double derivative to see which one is positive and which one is negative. If the double derivative is positive, it means you have a minimum. If the double derivative is negative, it means you have a maximum. So I took you all the way through that first question. You can see from the answers that I provided that we ended up with the answers 3, 6. And then you would say, therefore, the numbers are, and I'll let you write that out, and you make a concluding statement there. So I'm going to just get you started on question 2, and I won't go all the way through it, but each of these questions depends on you being able to make first of all, some kind of a function or an equation out of the information that's given. Secondly, for you to take the first derivative and set it equal to 0 to solve, and then to use your second derivative to show if it's a max or a min. So those are the 3 steps that you're going to use to solve all of the problems that you're given on this worksheet. For question 2, we have a rectangular field and we're going to fence it off in between. So we've got smaller sections. We've got 4 smaller sections. So when we're finding area, perimeter, and things like that, we usually label our sides as length and width, or x's and y's. So if we choose to label our small side with x, then all of these sides are going to be x's. And if we want the longer side to be y, then this long side and this long side will be y. So we have 500 feet of fencing. That means that all of my x's, 1, 2, 3, 4, 5 x's, and all of my y's, there are 2 y's, have to add up to a total of 500 feet of fencing. Now, if we want to maximize the amount of area that we're going to get, then we need a formula for area, and the area formula is x times y, or length times width. So I'm not going to do this one all the way through for you, but what you first have to do is take this equation and rearrange it so that you can solve one variable for the other variable. So in this case, you're going to have to divide everything on the right-hand side by 2. And then you're going to substitute that in place of y in the area equation. When you do that and you multiply it out, you'll end up with a quadratic equation, something with a squared, x squared term in it. You're going to take the first derivative, a prime, set it equal to 0, and solve for x. And then you should be able to solve for y. The last step is to take the second derivative of your area equation, a double prime, and test it to see whether or not you have a maximum or a minimum value for the area. So I hope that helps, and please give those a try. Try number 1 by yourself now that you've got the answer to take a look at, and practice that. Get really good at it before you try the other 4 questions. And email me your work if you get stuck on any of those other questions. Send me what you've got so far, and I'll try to get you going again on them. Thanks, Ola.